Assalamualaikum and greetings to my examiners. Welcome to my final year video project. My name is Muhammad Shafiq Aiman bin Muhammad Yati. I am Bachelor of Science Physics Part 6. The title of my FYP is The Reflection Effect on Solar Panel Performance in UiTM CAWANGAN Pahang Campus JENGKA. I am supervised by Encik Nazri bin Ahmad at Muhammad. For introduction, as we know, fossil fuel coal nuclear is a non-renewable energy, while wind energy, hydro energy, biomass, and also solar energy is renewable energy. Nowadays, the power use is quite high because of the residential, commercial, transportation, and industrialization. So we want to study about solar energy because we can get through our sun, and then we want to boost up with using the reflection of mirror to trap more sun rays to the solar panel. Okay, for the problem statement, we know fossil fuel is non-renewable energy and it is not eco-friendly, and then the installation of solar panel is quite high and we need to maximize the output of the solar panel. And then we need to make a comparison between mirror reflecting solar panel and a conventional solar panel. Okay, for the objective, we need to make a comparison of the efficiency the solar panel with mirrors and a conventional solar panel in UiTM Cawangan Pahang Campus JENKA. Okay, for the first literature review by Akshavir et al. 2021, finding is the concept of bifacial PV with sandwich thermal energy, which is produced 1.21 times power output. And then for the modified bifacial PV using mirror reflection shows that high power output compared to a conventional photovoltaic. Alright, for the second one, Karimzadeh Kolamrudi et al. 2022, finding is the photovoltaic system use the cooling system due to high temperature will affect the output of the solar panel, and then the output of the power output shows different with the existence of mirrors, which is using the reflection of optical wave phenomenon. Okay, for the third one, which is Manso et al. 2020, finding is using mirror to enhance the energy output by using theory of photovoltaic with different angle, and then the output of conventional is 11.99 and mirroring is 13.49%. Okay, for the methodology, so on solar panel A, which is we provide mirrors, we mirror as a reflector, we use a word C to trap more sun rays, and for the solar panel B, we use conventional solar panel. And then after the setup, we take the reading of voltage, resistance, and current, and then we plot the IV graph and PV graph, and then we take result from the graph, and also we calculate the power and efficiency, and we compare the result between conventional solar panel and mirror reflecting solar panel. Okay, now we move to the sunrise diagram on the left side, which is the solar panel A. From the sun, the incident ray will be for example will be trapped by the law of reflection. As for example, between these two stem mirrors, the incident ray will be reached on lower mirror and will be reflected to the top mirror on the left side, and from the top mirror will be reflected to the solar panel. Same goes for the left side. The incident ray will reach the lower mirror and will be reflected to the top mirror on the right, and it will be reflected to the solar panel. But as we can see on solar panel B, the incident ray will be reached directly to the solar panel, and it will release to the surrounding. Okay, for the results, on the left side is the setup of the solar panel A, and on the right side is a setup of solar panel B. And then we use the multimeter to take reading of ISC, VOC on both solar panel. So this is the IV table. So we take average from 3 times collecting data, and we use different resistance, which is 20, 50, 68, 82, and 100. And VOC is 19.73, and for ISC is 1.81. And this is the reading of the voltage and current for solar panel A. From the table above, we plot the IV graph, and for the Imax is 0.911 ampere, and Vmax is 19.32 volt. Based on the graph above, we know Imax is 0.911 and the Vmax is 19.32. So we can calculate the maximum power output, which is 17.6. We use the formula P is equal to IV. So this is the solar panel B, which is a conventional solar panel, and the Imax is 0.88 and Vmax is 19.25, and we use this same as solar panel A on resistance, which is 20, 50, 68, 82, 100, and VOC is 17.73 and ISC is 1.82. This is the PV graph of the solar panel B, and then the Vmax is 19.25 volt, and then the max power output is 16.94 because the Imax is 0.88 ampere. Fill factor is essentially a measure of quality of the solar cell. It is calculated by maximum power divide with ISC times with VOC. And then this is on the right side is the example of solar panel A. And as we know, solar panel A fill factor is 0.49, while B solar panel is 0.47. For the efficiency on both solar panel, we use Pmax over solar irradiance times with surface area, and we times with 100 to get the percentage. Okay, the solar irradiance would be 1000, and the surface area on both solar panel is same because we use the same solar panel, which is 0.3016 for the surface area. And on the right side is the example of solar panel A efficiency, which is 5.84%, while solar panel B is 5.7%. And as we can see, with the help of mirrors as concentrator, help to increase the efficiency of solar panel. As the conclusion, we know solar panel A, mirror reflecting solar panel, have the higher efficiency than solar panel B, which is the conventional solar panel. And then we assume that mirror as a concentrator boosts the output of the solar panel to its optimum state. And then we consider the project is achieved. That's all from me. Thank you for listening. Assalamualaikum.